In last lecture, we studied about regression. Okay, regression basically predict the values. But remember, these values are of continuous pattern. We will study about classification. In classification, we will determine the discrete value, kind of a binary value, yes, no kind of thing. But right now, I would like to continue the regression in detail. That is, you can say, it is kind of a function in which we learned the continuous value. In regression, we learned the continuous values. We can predict basically, okay, anywhere in a continuous fashion. For example, temperature of a classroom, okay, heartbeat. So all these are, temperature is varying from point to point, from instance to instance. This room temperature from location. Okay, certain parameters can be involved, but we can determine the temperature in a continuous fashion. So, because it is varying, okay. Once we are talking about the linear regression, it can be done with the help of gradient descent, with the help of equation of normal, or you can say, if you want to talk about a little bit advanced level, then you can consider the batch gradient descent. This delta, okay, is used symbolic expression for gradient descent. If we are considering the two-dimensional object or two-dimensional things, or for a moment two-dimensional vectors in this plane, so some variables or some features, okay, some features as vectors are composed with some elements. Each element of a vector is known as some feature value, okay. For example, we are talking about 1 unit house, and in this we say the two feature values such that this is, okay, the power here is superscript, not a power, okay, is representing 1 unit house, and its subscript is representing its feature value. You can say here its living area, first one. The second feature, this, and we are talking about a 1 unit house. Will we change superscript or not? It should be same.
Same.
Same, brilliant. Usually we do not need to mention, okay, this one just for explicit meaning I did it. The second one, you can say number of bedroom. Here we are supposing, okay, predicting, hypothesis, that what should be the cost of that 1 unit house. So for this, we will write some hypothesis of this 1 unit house. I is representing, okay, number of example. We are talking about just visit 1 house, 2 house, 3 house, n number of house. Okay, m is example, and the features is representing till to the n, and here j is the fee. Here we are considering the index of examples 1 to m examples, and j features 1 to n. Okay, in a moment ago, what we did, we said this one is a 0, and wait here. We don't need to mention here. I am not going to mention 1 1 here. Okay, just ignore it here. Though it can be written 1 here, but I am just considering the super, because we are talking about the 1 unit house, or you can say simply it is the 1, or you may ignore it. And how many features? This is the benchmark thing. If we are talking about a house, then we should say it's a house, so it is kind of the intercept value. Okay, let me explain further. Then theta 1 x1 is the first feature, theta 1 is the weight of the first feature, area, how much area. Okay, x1 is living area, but theta 1 is multiple, is telling us how much weight of it. Second, theta 2 x2, the number of bedrooms, how many bedrooms. Okay, so 2. Yes, this is just 3. So this one here we know this is the 1 unit, or you can say it's a benchmark thing. We are talking about a house. So simply, or you can say generally, it is equivalent to 1. So we will have this expression theta naught theta 1 x1 plus theta 2 x2. This is the hypothesis. Okay, you can say
how much area?
So no. This is hypothesis is telling us about the price. If some house with these number of features, values, with its weight, okay, what should be the price of it? Okay, this is the thing. So here it's very much important thing. This is the intercept, and this is, you can say, some kind of a equation. Now we get it. This equation, let me highlight it with some different color. So this is some equation, and if you notice for a moment, this is similar kind of equation which I taught you in my first lecture. Yes, please.
So we just mentioned that I and j should start from 1 up to m and n.
Yes.
So how we could come across theta naught and x naught?
Yeah, this is the another thing. If we will talk about this, then n plus 1, m plus 1. Okay, so here basically your theta belong to if we are talking, so no, let me explain it. These basically dimensions. One is the benchmark dimensions, okay? N is the total number of features, M is the total number of examples, plus one in both the things is representing this one, first one. Okay, let me explain to you.
Like theta naught and x naught is representing a house with no feature.
You are considering the benchmark house. Okay, you are talking about house.
Yeah.
First thing is house. Okay, we do not consider other features of the house. Only we are talking about the house, one unit house. It's not a plaza, it's not an apartment kind of a multi-story building, single house. So it is representing with this one. In my some of previous class, I told you in our class teacher used to tell us one. This is the same thing. Are you getting my point? Existing. One unit house is there, but we are not talking about its features. That's why we are considering it's equivalent to 1. Are you getting my point or not? Still not clear? Somehow? Okay. Actually, the basic condition and this weight, this theta is telling you the basic parameters. If we are talking about the house, one house, and it should have one kitchen, one bathroom, okay? These are the basic things. So, basic necessity is available in this house. But this is not telling about the weight of other features. This is telling about the basic weight of the house. And this X naught is talking about itself a house. Okay? For example, if you allow me to proceed a little further, then you will get it. Okay, please. This one is an equation, and I said that this is the hypothesis. Okay, forget about this is the J value. So even you consider this or not a big deal. But let me write it again. That this one. Okay, here. So because this hypothesis depend upon the weight parameter theta and function of features, function of house. So you said this one. This is similar y mx plus b. What is the b? This is intercept. This is intercept. Here b and theta is both the same thing. What is the intercept? For example, you start some business. You are checking out your pocket. It can be 0. You don't have any single penny. Okay? It may possible you start your business from 10,000 or 10 lakh. It can be anything. But you are going to do some business. Okay? Currency value, it can be 0. Okay? But what is the thing? You are not doing anything else. You are talking about some business. Okay? For example, you are invest in cryptocurrency. Of course, you will invest with some basic amount. You can invest 1,000, 100, something, whatever you have in your pocket, you will invest it. Okay, this is the intercept, basic things. So another thing I said that 0, this is the very ideal case, but usually it should have some value. You should have some Okay, this and the starting value is representing the intercept. In my somewhere graphical formation, I mentioned that you started somewhere from the 0, okay? This is a very ideal case. But in this case, this is the x, this is the y, okay? And you can write y equal mx plus b. Your intercept in this case 0. But usually if you start some business or you start to learn, of course it can be started like this. So your this point is representing the b. And whatever the change, this is representing change, rise or run. Okay, this is m is telling you delta y or delta x. Along the x-axis, as you will move here, small change here, too much height you will gain. Is it okay?
Yeah.
So here you, as you move further, this all segment is generalized with this x. It can be 100, it can be thousands features. One house can be of 1,000 features. As I thought that n number of features. Okay, so, but of course, here we consider is equal to 1 because we are talking about the house, 1 unit house. Okay, so it's 1. So usually, and of course, theta is some kind of an intercept value. We start from some things. This is the situation. You got this hypothesis, right? Hypothesis. Is it clear?
Yeah.
It is nothing else except the equation. This equation. Simple, this equation. In my previous lecture, I said if you have one point and initial point and the final point, you can predict some value between the two, okay? The farming market kind of things. Remember?
Yes, sir.
Well, this is the thing. Nothing new. And this, this equation, let me rewrite it again for your concept crystal clear. You can write it like in form of a vector array, theta naught, theta 1, theta 2, transpose x naught, x1, x2. Of course, this is what? This is, you can resolve, okay? You multiply these two, you are multiplying two vectors. You are multiplying two vectors, or you can say these two vectors, theta naught, theta 1, theta 2. Okay, or you can either you can multiply this way or that way. Okay, for example, you are multiplying 1, 2, 3 with x, y, z element wise. Okay, this is one vector. This is another. You are multiplying. This will multiply with this one. This multiply with this one. This multiply with this one. Okay, so here in the matrix formation, so you can write x naught 1, x2. Of course, what I did, I just, instead of this, I considered the transpose here. Okay, flip the vector. So, you know the multiplication rule of two vectors or matrix. So, you will go like this. You will go like this. Okay, first element, theta naught, x naught plus theta 1, x1 plus theta 2, x2. Sum up, gives you one scalar value, and this scalar value is kind of a price of the house. And usually we are considering this x naught equal to 1. Okay? It is the first feature. First feature is what? It's the house. We are talking about the house. That's okay, it's clear. It's existing, okay, identity. So this is the, okay, benchmark, you can say the initial weight, or you can say intercept. Initial weight is what? Intercept value, whatever you have in your pocket. And so this is the other things. You can write this theta naught, theta 1, x1 plus here 2, x2, and this is your hypothesis function. Is it clear, please? So this proves we can write in short form, we can write one hypothesis function like this, transpose some x. I am generally using single x for representing the too many x, and one big theta for representing too many value of weight function. Or we can also write R. We can also write, I hope you will not mind. The same thing. You will get the same thing. If you will multiply the transpose factor, okay, same thing. Is it okay?
Yes.
Thank you so much. This is the first point I would like to speak out. Okay, now it is pretty clear what is the hypothesis about the house values.
Predict the house.
Predict the house value. But problem is this, whenever we are predicting with the help of deep learning, by considering some data, we want that our prediction should be accurate. Okay? For this purpose, of course, there is some reference value. For example, I am buying this pen for 100 rupee. I bought it from market and its original price, okay, tag value, but I am showing to you and I am asking, please predict its price. Guess it. Okay, you will utilize your mind. You already bought too many pens from the market. You are also familiar with this digital board. Okay, many things you will calculate and you will guess it. It can be, might be 100, might be, okay, 150.